This video is going to be about factoring polynomials by grouping. This is a technique that is used when you have polynomials that have more than 3 terms. Polynomials that aren't technically quadratics that you could factor with those skills. Here's an example of a polynomial that has more than 3 terms. Now we have 4 terms, so factoring with our Xbox, Punnett square, Magic X, any of those methods you guys like to use aren't going to cut it. So here's how it works. First, we think of this actually as 2 different problems. I'm going to kind of split it down the center. On the left-hand side, we want to find a GCF. The GCF for both these is x squared. Let's go ahead and factor him out of those 2 terms on the left. You end up with x minus 2. Now we look at the 2 terms on the right. I notice that there's a GCF of -9. So let's factor out -9, and I'm left with x minus 2. You know that the GCF and the grouping worked properly when you end up with the same exact thing inside the parentheses. So now it's time to rewrite this problem. We're going to take what's in the parentheses, and he's a new GCF being pulled out to the front. So let's write down x minus 2. And then what is left over, this x and this 9, that's what goes into our other set of parentheses. And there's our answer. If you want to check your work, you can always check it by foiling. Okay, at this point, I suggest that you pause the video and try out this problem, and then you can unpause it and watch how I do it. Okay, welcome back. So here's what I would have done. I would have split this problem into 2 pieces. The first 2 have a GCF of x squared. I'm left with an x because 3 minus 2 is 1. I'm left with a 5 because the x squared is coming outside. The GCF of the second 2 would be 8. 8 goes into 8 and 40, leaving me with an x plus a 5. If ever you want to check your work, you can always distribute, and you should get what you have right here. Okay, now it's time to rewrite these. Let's put the x plus 5 in front, followed up by all the leftovers, our x squared and our 8. Okay. Let's take a look at a different kind of scenario. In this problem, yes, we could start the factor by grouping first. But what I do notice about all 4 terms is right off the bat they all have x. That wasn't true in the last 2 problems. So I actually have a GCF from the very beginning. So let's actually take that and factor out an x right now. So we factor out an x from the x power 4. Now it's a power 3. 6 x power 2 plus x minus 3. So the x coming out has brought down all the powers by 1. Now it's time to think about this split and think about the 2 sides of the problem. My GCF for my left 2 would be a 2x, and the most power that can come out of both of them is a 2. Alright, 2 divided by 2 is 1, and 3 minus 2 is 1 power, so x. Negative 6 divided by 2 is negative 3, and the x power 2 is coming outside, so no x is there. Okay, now let's look at the right 2 terms. I notice that there's actually not a number that I could think of that divides into both these, and also they both don't have x's either. So when you have a situation like this, you still have a GCF. It's just your GCF is only 1. I can only technically take out a 1 from both of them. X divided by 1 is still x. Negative 3 divided by 1 is still 3. this actually works out well because you notice I still end up with the same exact thing inside the parentheses. Okay, let's write the x minus 3 first, followed by the 2x squared plus the 1. At this point, a lot of students are going to want to stop here, but it's important to notice that from the very beginning, I put an x out in front of everything. So technically speaking, we need to make sure that we have brought that x down with us each time we do the problem. So this is our final answer. So why don't you go ahead and try this problem, pause the video, and then unpause it, and you can see how I do it. Okay, welcome back. So first I look across all 4 terms and I notice they all have an x. So let's pull out that GCF of x, rewrite. The 4 goes down to 3. The 3 goes down to 2. The 2 goes down to 1. And the 12 no longer has an x. Split this into 2 problems. I'm going to use a GCF of negative 12, and the biggest x power is 2. The leftovers are going to be x plus 4. GCF of the right 2 terms is negative 3. Pull them out, you're left with x, and 12 divided by negative 3 is going to be positive 4. I see that I've done this right because I have x plus 4 inside of both parentheses. Don't forget that we pulled out an x in the very beginning, so let's bring them along. Now it's time to rewrite our problem. There's the x from the beginning that we pulled out, followed by our common parentheses of x plus 4, ending with our 2 GCFs put together, 12x squared minus 3. And remember, you can go ahead and FOIL and distribute the x to check to see if this turns back into our original problem. That's how you know if it's correct. Okay, I hope this clears up factoring by grouping. And if you have any questions, go ahead and leave a comment, and I'll see you back in class.